Okay, so let's get started then. Got a big day ahead of us here. An hour and 15 minutes to explain database design, what databases are for, how we're going to write a database query or question, and we'll somehow tie this all back to Project 3. So, good news is, I've done this before and I know it can be done in an hour and 15 minutes. Because as a business student, you don't need to know too much about the technical details, and if we keep it at the business level, I think we'll be able to get through it in an hour and 15 minutes. Now, there's all kinds of slideshows coming at you on the Moodle page, not from me, but I am going to bounce into this one, which is Tech Plugin T5. I'm not going to go through the whole thing. I'm just going to kind of get a base here, and then we'll spin off into a couple of other areas once we do that. So in Tech Plugin T5, which is a good place to start, you start with what is a database and what is a database management system. You also do this with the slides from our chapter 6, so they're both saying the same thing. So there's overlap here, and we'll try to get the best from both as we go through. So to get some of the lingo down, then, a database basically maintains information about various types of objects, such as inventory, events such as transaction, people, maybe employees, maybe students, and places such as warehouses, classrooms, that kind of stuff. Now, that's what a database is in its purest form. But the same is, that's what a spreadsheet is in its purest form, or that's what a document is in its purest form. What do we use to create? Well, if you're creating a document, you'd use Word. If you're creating a spreadsheet, you might use Excel. If we're creating a database, we might use Microsoft Access or Microsoft SQL Server or MySQL. These are all products that we would use to work with databases. And those products then are called database management systems because they're primarily software. And they all kind of work off a consistent model called the relational database model. And the relational database model has been in existence for a few decades now. And it seems to be what all of these types of database management systems have in common, is that they all have the ability to create tables and create relationships between tables. The value of that is, if you've got a bunch of things connected, you can mix and match information from these connected pieces and actually form something from those connections. Unlike spreadsheets, where it's not easy to make connections between spreadsheets or even spreadsheet files. In database, we'll see how that can happen fairly easily. So, big question is, why do business students need to know about database design? Well, the answer to that question is very simple. You're the one that's going to have to write the check at the end of the design effort. Wouldn't it be nice to know what you're paying for? Even nicer to know that you've taken part in the design. So how do you take part in something that you know nothing about? Well, hopefully you'll know something about it when we finish off this section. So it is a good question, and what we can say right off the bat is anything that's designed in a database comes from the fact that it's needed to solve a business problem. And we all run individual businesses differently. And all of those individual businesses have different rules in the way they operate. Now, there's some that are similar, there's some that are the same, but if you want software, and particularly database systems designed for your particular business, then you'll have to explain to that designer, that IT person, what are your rules? Like, how do you run your business? And so there's nobody better than you to explain that. And It is all about business rules, such as one supplier supplies all our office supplies. A customer can exist without an order. An order is taken from one or more items. Oh, so maybe the IT person didn't know that. What do you mean you can have a customer that never ordered anything? Well, we can. We keep a database of customers in our business, and some of those have actually ordered from us, and some have never ordered from us. Well, are they a real customer? Yeah, they're a potential customer. So we want to treat them as a customer. We want to send out news releases to them. We want to send out discount coupons to them. We want to let them know what's going on because they're potentially going to buy from us. Well, the IT person might say, well, that's different because, any place else I went, there was never a customer without an order. Well, we're different, right? So you could find individual differences from one business to another, and that has to be explained. And it has to be explained in such a way that it's a conversation, because you couldn't possibly list all your business rules, right? That would just be an endless list. And then even if you did list them all, how can you be assured that the IT person is actually going to read them and understand them? So that presents a problem in itself. So what we reach for in a case like that is we reach for a model or a diagram of some kind that we can carry on this conversation with, so that we don't have to get down to the writing of paragraphs and pages and documents. And it's much easier if we can converse with a model, with a diagram. So that's what we use these entity relationship diagrams for, is we use them to have that conversation. And the good thing about it is that once you learn the basics of entity relationship diagramming, they're pretty easy to look at and they're pretty easy to talk about. If we look at what is an entity is like a noun in language. It's a person, place, or thing. An attribute is how we describe that person, place, or thing. It's the characteristics of that entity. We call those attributes. So an example might be a customer entity can be described by having a customer number, first name, last name, street, city, so on and so forth. And all of those things that a customer has would be their attributes. So if we look at some example entities like a customer, an order, an item, a distributor, you see the individual rectangles with the entity name in it breaks down into the attributes that those entities have. And potentially as we move from one business to another, there could be different entities. So a customer in one business might have different attributes in another business. So we can't cast that in stone, right? Especially as we look at this was obviously a U.S. creation. They have city and they have state. Well, that's not going to work here. Zip code, what's that, right? So right off the bat, we say, well, that would be a fine list of attributes if you're working in the U.S., but not here in Canada. So, the attributes will change, but potentially the entities will remain the same. So the entity identifier then ensures that each entity instance has unique attribute value that distinguishes it from every other entity instance. So usually what we do is we give these entities some type of unique identifier, and that's really the crux of relationship diagramming. That's where the R comes from in entity relationship diagram. The fact that each one of these entities can have a unique identifier. And this unique identifier we call a primary key. And we use that so that we can distinguish things like two people having the same first name and the same last name. I have a class right now that has two students in it, and they both have the same first name and they both have the same last name. Yeah. I think it's the first time it ever happened. So I got to be real careful with those two students to make sure that I have a student ID number to distinguish them from. So that's what I'm going to rely on, is the student ID number. So everyone in here has a student ID number, and that's what we use to distinguish you from someone who may have the same first name, last name as you, potentially in this university. So in addition to unique identifiers, we might also have constraints. How the entity is stored. What is the significance of the identifier? Is it as simple as putting in a customer number, a distributor number, a student number, or we may have to look further at how are we going to distinguish one entity from another. There's also, as you've seen, attributes. Some of these attributes are very simple. A simple attribute would be first name, last name. A composite attribute may be taking the first name and last name together and calling it full name. So the attributes may also be single-valued or multi-valued. They might be stored or derived, so that if we know that you have hours of work and you have a pay rate, then we could easily take your hours of work multiplied by your pay rate and come up with a derived number. And that derived number may be your weekly pay. And there could be times where we don't have an entry. Maybe a person doesn't have a phone, so there would be no entry for phone number. But they would at least have to have a first name and a last name. Everything else is really up for grabs. Maybe they're of no fixed address, and maybe they don't have a phone number. So we'd have to allow for the unique opportunity where null values would come in. Null means nothing, right? So, yeah. So here's just an example of simple versus composite, where we would take street, city, and state and zip code and put them all together and create something called a full address, where we take first name and last name and call it a full name. So we could do that. We could collect individual attributes up into something larger and call it a composite address. We could also have single and multi-valued, so the customer entity allows only one telephone number for each customer. So what do you do if a customer has more than one telephone number? Well, we'd have to allow for that, right? We'd have to plan in our design for that to happen. Okay, so let's look at the diagramming itself. Okay, so let's start off here. The basic data relationships. There's only three basic types of relationships. One entity can be related to another by having a one-to-one relationship, one-to-many, or many-to-many. And that makes it real simple. So here's a one-to-one. And so what we do in a one-to-one relationship is we try to find a phrase that we can put in between two entities to make it read like a sentence. So we can say a town has an airport. And reading it back the other way, from right to left, I know we don't usually read from right to left, although in some languages they do. But if we were to read this from right to left, we would say an airport is located in a town. So we would have to change that phrase in the center. So a diagram like this has to make sense, reading it from left to right and right to left. And when it does make sense, you know you've got it right. If it doesn't make any sense, then that can't be, right? That relationship can't exist. If we look at building our diagram out further then, and looking at something like customer, order, item, and distributor, we might say that the customer has, or customer places an order, and allow for the possibility that customer could place many orders. So we have one next to the customer entity, and we have M that represents many next to the customer. Now, there's other ways of signifying that. You don't always have to put in the one and the M. There is diagramming techniques that we'll look at in a minute that probably is a little clearer in expressing that. And here's an example of a many-to-many relationship where you could put in M for many, or you could put an N for any number. And of course, any number, that's what the N stands for. So this customer could order any number of items, and any number of items is ordered by many customers. So see, it works well reading it from left and right. So the good news is, that's all there is. Like that's all there is in entity relationship diagramming is three basic relationship types. Let's go over to our book and see what the diagramming looks like there. Here's a diagram from our book. Now, one thing you'll notice is there's different methodologies being employed here. And the methodologies being employed is that they don't believe in writing a 1, and they don't believe in writing an M. They believe in a different notation. So the notation that we're seeing here is that a supplier provides one or many parts. And that's what the solid bar and the three lines, they're commonly called crow's foot. Because if you ever looked at a crow's foot, potentially it would look like that, right? So a crow would have 2 feet. That would be your crow's foot. So it's formerly called crow's foot. So a supplier, reading it from left to right, produces one or many parts. And reading it from right to left, a part is supplied by one and only one supplier. That's why it's double bar, coming back right to left. So, here's the scenario. The scenario is you would go into a meeting. The IT people would pop up this database design, and they'd say to you, "What do you think?" And you would look at this and say, "What's all the little lines mean?" Yeah, hopefully you won't say that. Hopefully you'll say, yeah, that looks like what we do. Yeah, or wait a minute now. A part is supplied by one or many suppliers. You have to change that because we don't operate that way. No, we get our parts not just from one supplier. We get our parts from many suppliers. So you're gonna have to change that. Oh, okay, not a big deal. We'll change that. How do you like the part and the line items? Line items are really what they say. If you picture this as an 8.5 by 11 sheet of paper, and you can order, many things. Each one of these would be a line on your order. How do you like that? Well, let me see now. A part is ordered on a line item, and these line items can be one or many. And then coming back the other way, a line item contains one and only one part. Yeah. So we would only, we'd only have one part here. Maybe on line 1 we'd have a widget, and line 2 we would have an umbrella, and line 3 we would have a washer. So yeah, every line is an individual part, an individual thing that we sell. Yeah, that looks all right. And so how do you like line item in order? A line item belongs to one and only one order, and an order includes one or many line items, which means that a person could order one thing, or they could order many things. Well, yeah, I suppose you could have room to order many things, but if you only wanted one thing, you'd only have to fill out one line. Sure, that would work. No problem with that. So, coming into this meeting, you could say, yeah, that looks pretty solid. And do you have to know behind the scenes what they're going to do? Not necessarily. You just know that at the end of the day, you're going to have an ability to work with this database. There's going to be screens, there's going to be reports, there's going to be queries, there's going to be all that after we get through this stage. Because if we don't do it right here, none of that is possible. So, you would be able to then take part in that discussion just by knowing those few simple notations, and that what lives inside boxes are entity names. And of course, the supplier has a list of attributes that we're not going to list here, but we could get to that stage at the next meeting. Tell me more about a supplier. What do they look like? Well, they have a name, they have an address, they have a unique number. Oh, okay. So that, that would take care of that. So looking at that then, and kind of relating that back to a few examples. Here's a sample database design that I used to use for an assignment in this course. That's why I have assignment 3, suggested solution, and I'll just take that out of there. Because in assignment 3, what I used to ask the students to do was to create a database from something they know very well, like taking courses at a university. So design a student database to keep track of students, courses, and course instructors. So then I would say, okay, what are your entities? Who are all the players that take part in this? Well, there's instructors, there's courses, there's students, and sometimes there's course sections, right? Even if there's not more than one section, there's usually just one section, and that's, sometimes we give it a letter A, and sometimes we don't even bother giving it a letter if there's only one section running, right? But they're actually called sections. So what we would do in that then is we'd start capturing, well, tell me more about instructor. Oh, instructor has an ID, they have a name, they have an office location, they have a phone number, and they have an employment status. Huh, okay. So what about a course? The course has an ID, a title, and a number of credit hours. A student has a student ID, a name, and a phone number. Of course, there's more than that, we know, but as an example, those would be the types of things. And the course section has a course ID, section ID, instructor ID, student ID, and grade. Oh, that last one looks kind of weird, but yeah, it has to be to make it work. It has to be. So if we look at some sample data, we would say, well, this is what an instructor looks like if we were to fill in the data. This is what a course would look like, a student would look like, and a course section would look like. Sometimes we have to model that, right? Sometimes we have to put real data in to see if it would actually look okay. Did we forget anything? That type of thing. So one of the things that we don't think of is, where do the numbers come from? For example, your student ID number. When I look at a list of students, I usually look at the student ID numbers first, because I can tell a lot just by looking at the number. Like right now, we're up into 130,000, I think. 130,130,111. That would be maybe even higher. 135, 199 or whatever. That tells me that if you're up into the 130s, especially the high 130s, then you're a fairly recent student. So you probably registered here last year, and this is probably your second year. If I see a low student number, something like 78,456. That's 78,456. And say, oh, that's maybe a mature or part-time student who's picking away at courses over a number of years, and they probably registered, I'm guessing, about 8 years ago. So you can tell a lot just from student numbers, because the next person that walks in the office over there and registers, they're going to get the next number. See, the numbers are sequential. So my student number, when I was a student here, was that 13559. So I was the 13,559th student to walk through the doors. What year do you think that was?
About 1960s.
The university started in '69.
Probably late 70s.
Yeah, and I came along in 1978 to register as a student. So I came along like 9 years later to register as a student. And that's the number they gave me. So now we seem to be going like about 10,000 numbers every 2 years. That seems to be the speed we're moving at. Yeah, so a lot faster than that for sure. We've grown, we've become a lot bigger. But there is a person on campus right now that had a student number of 1, and they're still here. Now they're not a student, right? They're a professor, and that person used to be the president, and she has a monument named after her out in front of the Robertson Library. Elizabeth Epperly. She has an employee number of 1. She was the first student to formally register for UBI. So somebody's got to get the number 1. That's her. So yeah, sequential numbering. I mean, if you don't have anything else to go by, that's as good as anything, right? Just give the next person that registers the next number. That way everybody has a different number. So will this work? Like, we go into a meeting, we sit around at the table, we look and say, yeah, one instructor teaches many course sections. A course is offered potentially in many sections. A student enrolls in many course sections. A course, reading back the other way, a course section is enrolls kind of 1 student at a time. Yeah, this might work. Only way to know for sure is to take it into software and see if it does work. And so this is what you'll be doing in your project. You'll be coming up with a database design, and I don't need to see this because when you put it into Access, I will see it there, right? I will see if it works. So let's see this this glorious design in this course registration sample database and see if it actually does work. So here's our courses and our course section and our instructor and our student, and now we're in Access. And let's see what this looks like. Here's my relationship diagram. Another set of notation that means relatively the same thing. I know. Enough with the notation, right? So let's even make it look like it did when it was in Word. Okay, let's move the boxes around so it even looks like what I had there before. That look familiar? I'm getting there. There. Now if I switch back to Word, do you see that? Instructor, course, student, and they all tie into section, right? I go back to Access, instructor, course, student, all tied back into section. Yeah, that's the same thing, isn't it? And those attributes are in the white boxes there. Those are the attributes that the entities have. So I will see your database design because I'll have your access file and I'll be able to pop in and see that. So yeah, that is exactly what you'll be doing. In actual fact, your project is easier than this one. You can thank me later for that. Yes, easier. We like easy, right? But yeah, it has to be easy when you're starting out. You know, you can't start with anything too grand, but you know, we made it work.